everyone. I'm Aarya Rajaram from Dream Team in Science Olimpiad. Today I'm going to be going over my tennis ball catapult presentation and demonstration. Before we get into the real presentation, let's go over some history facts about tennis ball catapults. Catapults emerged in ancient Greece around 399 BC and also was evolved from handheld combat bow devices. The catapult dominated for centuries as a fear-inducing weapon of war. So without a catapult, there's no war. In the mid-20th century, catapults made their way to aircraft carriers. In the 21st century, a new technology using aircraft catapults emerged: the electromagnetic aircraft launch system, EMALS. So what I'm going to be covering in this presentation, I'm going to be going over the background of a tennis ball catapult, the components I used for this project, the measurements of my catapult, and demonstration. So the background on tennis ball catapult. So I'm going to be going over four main focuses: the concept, the definition, the role of gravity in air, and how it works. The concept of a tennis ball catapult. When the elastic potential energy is released, it turns into kinetic energy, moving energy. Then the gravity eventually pulls the ball back to the ground, pulls the launch object back to the ground. The distance of the object traveled is determined by the amount of kinetic energy, gravity, and the resistance by air. The definition of a tennis ball catapult. A catapult is a launching device that allows us to experimentally observe projectile motion. And a catapult is also a mechanism that forcefully propels objects like stones, spears, and other projectiles. Role of gravity and air in the tennis ball catapult. The gravity is the reason that tennis ball is constantly being accelerated. On the other hand, the air forces it to the opposite direction. When the kinetic energy weakens, the gravity takes over and pulls the ball back to the ground. And finally, how it works. A catapult uses the sudden release of stored potential energy to propel its payload. In this case, the tennis ball is the payload, and the stored energy is stored energy in the spring and the wooden stick. The components I used to build this tennis ball catapult. I used 1-inch screws to put it together. I used a rope holder, so instead of pulling the rope, there's something that can make it easier to pull. And a tennis ball, of course. And I used a swing bracket, and I used that so it can swing the wooden stick. And I used an eye bracket, and I used the spring. The spring comes in when I store the potential energy by pulling the wooden stick back when I'm about to launch it. I used the L bracket, a paper cup to hold the tennis ball when I launch it. I used 8 wooden pieces, which are at 1 foot. Now let's go measure the catapult and experience it in real time. Okay, so now we're going to be measuring the measurements to see if it's well within the range. So I have 3 measurements I'm going to be focusing on: the width, the length, and the height. The max limit for the width is 40 centimeters, and then the max limit for the length and the height is 50 centimeters. So let's see if it's well within the range. First, let's measure the width. Okay, so right here, it shows 32 centimeters when the limit was 40. So for the width, we are good to go. Now let's go measure the length. And then just to say, the length max was 50 centimeters. Okay, so right here, as you can see, it's 39 centimeters when the max was 50. So for the length, we are also good to go. Now let's go measure the height. Oh yeah, and before we start, to make it easier, I'm actually gonna use a wood. So I'm gonna make it stand vertically, and then measure it, take a pencil right over here, and then measure where the cup is, the end of the cup, and I'm gonna put it on the ground and measure it. Okay. Okay. So as you can see right here, it's 49 centimeters when the max, limit was 50. So for the height, we're also good to go. So as you can see, for all these three measurements, it was well within the range. So in the next thing, I'm just gonna give a quick preview before we start our demonstration. So in total, we have 8 wooden sticks. There are 4 wooden sticks as the base. Right here. 2 wooden sticks vertically, and then 1 horizontally. Got some L brackets right here, I brackets, a spring, there's a swing bracket, a paper cup, some screws, and a tennis ball. Okay. And one more thing I forgot to mention. So I was really excited after I finished this project. I wanted to test it out so badly, so I went here, and then I pulled it back with the string, but then unfortunately it was keep moving everywhere, and I was like very shocked. So I tried it again, and it was keep moving everywhere, like that. And since it's lightweight and it keeps moving, it couldn't stay in one place. Even if I put both of my legs on it like this, it still wouldn't stay put. So I was thinking for a little while, and then behind me I saw some salt bags, and then I decided, to make it more stronger. Should I add some salt bags? And then I added it. Then when I tested it out, it was actually better. So then I decided to put some salt bags. And one other thing. And one other thing. So right here, from the catapult to the purple basket, it's set at 2 meters. And then from the catapult to the pink basket, it's set at 4 meters. So I'm hoping it gets somewhere in between one of those heights. Okay, so now let's go measure our catapult. Let's go demonstrate. Okay, so now let's launch our tennis ball catapult. So I'm gonna pull it, and that's how I'm storing the potential energy. When I let it go, and when it's in the air, it turns into kinetic energy. And then the air forces it to the opposite direction. And then the gravity pulls the ball down. So let's launch this. Okay, let's do it in 3, 2, 1. Okay. So it landed a little bit out after the 2 meter set. So right over here. Okay, let's measure it from there. So right here, it shows 2 meters, and it shows 2 meters and 50 centimeters. And that's great. So to see if it's consistent, let's do it again. Okay, so again, storing potential energy, when it's in the air, it turns into kinetic energy. Air forces it to the opposite direction, and gravity makes it drop to the ground. Okay. 3, 2, 1, go. Okay. So let's use this chip. Landed right here, close to the 4-meter target. Like around here or something. Now let's measure it. Exactly. So that is, we can say 3 meters. So that's amazing that we got 3 meters. So as you can see from what we got, it was really consistent. So I'm glad it worked out and it was really successful. And thanks for listening and thanks for your time.